Sige. So, well, good morning, everyone. Good morning, ma'am. We are the group one, and we are tasked to report about the flame test, experiment number 2. And for our first reporter, let us have Ms. Perez for the introduction.
Introduction: A flame test is a procedure used to test qualitatively for the presence of certain metals in chemical compound. When the compound to be studied is excited by heating it in a flame, the metal ions will begin to emit light. Based on the emission spectrum of the element, the compound will turn the flame a characteristic color. This technique of using certain chemical compounds to color flames is widely used in pyrotechnics procedure, the range of colors seen in fireworks display. Objectives: Perform flame tests of metal cations in order to observe their emitted colors. Match the flame colors observed to a pertinent of a visible light. Determine the frequency and the energy of the flame. For the flame test, let us have Ms. Gapa to show us the schematic diagram of the procedures on how to do it properly.
So this is the schematic diagram of the procedure. So the first thing we do is to put on your safety goggles and an apron for our safety when we are doing an experiment. Then obtain a wood splint and the barium chloride solution. Then dip the wood splint into the solution and allow it to soak for 1 to 2 minutes. Then light Bunsen burner. Use caution. Then remove the splint from the solution and hold the end of the splint into the flame. Do not burn the splint. Then observe and record the color of the flame. Then after you observe and record the color of the flame, repeat again the step 2 to 6 using the remaining chloride solutions. Then obtain an unknown solution from your teacher, then record the number of your unknown. Then soak a wood splint into the unknown solution, then hold the splint into the flame and record the color of the flame that is produced. Then using your data, identify the metal ion in your unknown solution. So for the guide question, I'm giving the floor to Ms. Mojica.
Good morning, everyone. Good morning, Ma'am Risa. Ay, hindi lang po ako mag-on cam, ma'am, ha, kasi mag-lag po ang aking Zoom if mag-on cam po ako.
Okay, sige.
For guide question number 1, do you think we can use the flame test to determine the identity of unknowns in a mixture? Why or why not? Our answer is yes. We can determine the identity of unknowns in a mixture through flame test because different tests have different colors. And if these colors are in the unknowns of the mixture, it will show that the compound is in the mixture by showing the same colors. The flame will turn different colors based on which metal is in the substance. Number 2, why do different chemicals emit different colors of light? Our answer is chemicals emit light when the electrons return to lower energy levels and releases quantum energy. The color of the light depends on the difference in energy between the two levels. The different mix of energy differences for each atom's procedure produces different colors. For the guide question number 3, I will give the floor to Miss Chapani po.
Good morning, everyone. For the question number 3, why do you think the chemicals have to be heated in the flame first before the colored light is emitted? Chemicals have to be heated in the flame first before the colored light is emitted because the heat of the flame excites the electrons, and when chemicals are heated, the atoms spend time in a higher energy state. Then they jump to a higher energy shell and emit light while falling back down to the low energy state. For the question number 4, fireworks are made by combining metals with explosive materials. Using your data, which metals do you predict would be used in the production of green fireworks? In our data, we have predicted that the metal that produces green fireworks is copper. For the data table, Ms. Olarte will be discussing it.
So good morning, everyone. In the data table, the metal ions we have are sodium, potassium, calcium, lithium, strontium, and copper. For sodium, the color of the flame produced is yellow. For potassium, the color of the flame produced is lilac. For calcium, the color of the flame produced is orange. For lithium is red. Strontium is red also. For copper is green. So for the next slide, which is our conclusion, the reporter will be Mr. Hernales.
In chemistry, flame test plays a vital role in determining the identity of the possible identity of a metal or metalloid ion found in an ionic compound. And it is qualitative test to know and identify the presence of certain metals in chemical compounds. While making this activity, we've learned about when it comes on how to do the flame test correctly, determine the frequency and the energy of the flame, observe what color does a certain compound emits, and the sequence of the procedures in order to come up with accurate results. We've also learned that wearing proper protective gears and following instructions are necessary, especially that we should be cautious when we conduct an experiment inside the laboratory to avoid danger or any accidents. So before we end our reporting, ma'am, mag-play kami ng video for the flame test to be more emphasized.
Walang audio.
Di ba marinig, ma'am? Wait lang.
Wala. I-share sound daw. Napin mo sa view options, share sound.
View options. Saan ba makita mo?
Sa setting, hanapin mo daw yung like view option sa taas. Meron. Share sound.
Ito.
Okay. Sige, go. Ulit mo natin.
And 2
Marinig na, ma'am.
ions. We're going to do a flame test on a number of selected compounds, primarily group 1 and 2 ions. And these are aqueous solutions, and we have just a inert metal loop. We're going to dip the end into the solution and put it into the flame. And that excitation, characteristic color, is like a fingerprint for an element. So we're going to look at a number, and then we're going to ask you to identify some unknowns. Potassium. It should be a lavender, this is barium, it's a green. This is calcium. Calcium. Sort of a yellow-red. Strontium. This one's a pretty red one. This is lithium. Sodium is a bright yellow. And then the last one is copper. And this is the most vivid of all of them. Nice green.
So that's all, ma'am. That ends our report.
Okay.
Ano ba takot mo?
Sige. Thank you, reporters. Pakibalik doon sa inyong slide. So this one is the flame test, ha? The flame test. This one is qualitative testing in chemistry. Qualitative because we don't have numerical data. We do experimentation in the laboratory, but then at the end of the experiment, you will just have the description of the flame produced by the different metals or ions. So again, we don't have numerical data here. Instead, colors lang lahat yung ating isusulat sa datasheet. Now, this flame test is used for identification. So for example, we have solutions and we don't know the component of the solutions. So we can do flame test to first identify what ion is in it or anong ion yung na-dissolve doon sa solution na yon. But most of the time, flame test is used for metals. Metal ions, especially groups 1 and 2 in the periodic table. So the alkaline metals and the alkaline earth metals. Though we can have other metals pa like copper, pwede din natin siyang i-flame test kasi magpo-produce din siya ng unique color sa Bunsen burner. Pwede ko mag-request of control. So that, can I do that? Sige daw. Saan ako pindutan kani? Arrow? Yeah. Sige. So that's the flame test, ha. Now, what's the principle behind the flame test? We have here excitation of the electrons. So that is the reason why we really need to subject it to heating kasi para yung ating electrons of our ions will have the energy. Mag-a-absorb siya ng energy, and once it absorbs the energy, it will jump from the lower ground state or the ground state mismo to a higher energy state. However, that is just momentarily. Magbabalik pa rin siya sa kanyang ground state or yung lower energy state ng electrons, and as it goes back, mag-emit siya, i-emit niya yung energy na yon na once na absorb niya, and then yung energy will be in the form of light, and then different colors yun sila kasi depende yun siya sa electromagnetic spectrum na matatamaan ng energy as it goes back to the ground state. So that is the rationale behind the flame test. Later na yung procedure na lang. Okay, sa guide questions muna tayo. Do you think we can use the flame test to determine the identity of the unknowns in a mixture? Why or why not? So your answer here is correct. Yes, I have said, as I have said a while ago, flame test is most likely used for the identification. Okay, sige, I see. Identification of our ions or even our metals in a solution. That is due to the characteristic colors of the metals or the ions na ipoproduce nila when subjected to flame. So do not forget in doing the flame test, it should be non-luminous flame or the blue flame. So you really have to open fully the air hole for the Bunsen burner. Kasi pag mag-luminous tayo or yung orange flame, hindi natin makikita yung colors na yan. So that will be not enough energy for the electrons to jump to a higher state, or the color of the luminous flame will hinder the color produced by the metals. Remember, we have the excuse me, the orange flame for the luminous, and then 'di ba nakita ninyo kanina sa video nila na most of our metals will produce orange, yellow, or a red colored flame. So yan yung reason bakit sa blue flame tayo or the non-luminous flame. Now, why do different chemicals emit different colors? So the color is actually dependent to the energy. So the energy is coming from the heat, right, from the Bunsen burner. So i-absorb yan siya ni electrons, magja-jump siya to a higher energy state, and then it will just go back to the ground state. I-release niya yung energy. So the energy being released here is doon sa kanya nakadepende yung color na mapuproduce ng ating atom. So kung malaking energy, ibang color yun siya sa electromagnetic spectrum, and then kung maliit, ibang color din yun siya. So when you say electromagnetic spectrum, yan yung spectrum natin sa radiation. So radiation pa rin naman kasi yung energy na i-release ni electrons. So 'di ba kasali doon sa ating electromagnetic region ang visible region, and yan yung visible light talaga natin, different colors just like sa rainbow, 'di ba? Ang rainbow may different colors. So iba-ibang energy din yan sila. Kaya yun yung nadidetect ng ating eyes. Now kapag sa ions naman, ganun pa rin. As they release the energy, now since these energies are of different na values, so yun din yung makikita ng eyes natin, iba-ibang color. So that is the reason why our chemicals emit different colors of light. Okay, why do you think the chemicals have to be heated in the flame first before the colored light is emitted? So this one is being answered a while ago. We have to heat first so that to give the energy to the electrons para may ma-absorb sila na energy, and that mag-jump sila into a higher energy state. So para pagbalik nila dun sa ground state, ayun, mare-release na nila ang color. So etong flame test is used in pyrotechnics. So aside sa explosives na nilalagay natin in a firework, that will be a oxidizing and reducing agent. Aside from that, maglalagay tayo ng metals or ions in the fireworks para makuha natin yung desired color natin sa fireworks. So in this one, if you want to have a green fireworks, yes, you can have the copper, but the copper kasi is dependent kung ano yung kasama niya, kung halogen like copper chloride, copper bromide, minsan green siya, minsan blue. So kung gusto mo talagang green fireworks, the answer here is barium. Kaya lang wala kasi doon sa table, no? Kasi depende kasi dito nakadepende sa data. Pero just take note that if you want to have a green fireworks, you can have the barium. That will give us the green fireworks. Kasi yung sa procedure, barium pero wala siya sa inyong table, no? But that's okay. So let's check. Yellow. Sodium is yellow. Yes, that is correct. So if you want to have a fireworks na color yellow or color orange, it's between yellow and orange actually. So we have here the sodium. Now if you want to have it lavender or lilac or violet, that's potassium. For calcium, there are references that will describe the flame as orange. Meron din namang red kasi may shade of red pa rin si calcium. Sometimes there are references that describe the color of calcium as brick red. If I'm not mistaken, brick red yung calcium. So yan yung shade niya sa red kasi lithium and strontium are also red but different din yung kanilang shade. I think lithium is more of a crimson red if I'm not mistaken. Different shade kasi basta however red silang lahat. And strontium or baliktad, the lithium is the bright red, as in bright talaga yung color niya, and then the strontium is the carmine red if I'm not mistaken also, and then copper is green. Let us check with this one. I-stop share ko siya ha. Kasi yung sa video na pinakita nyo, solution yung gamit, no? You can do that, solution. Kaya lang, kung konti lang yung madala doon sa loop, minsan nahihirapan tayong makita yung color ng flame. Kaya ulit-ulitin natin siya. But meron tayo, pwede din tayong powder or what do you call that? Solid material of these elements. Mas klaro kasi yung kanyang color kapag kaganon. So wait lang ha. Hanapin natin siya. I'd like to have the wood splint para mas klaro. Wait lang, hanapin ko lang.